Welcome to Moose Tales. This is John with 2 Moose Home Inspections, and I have some short home inspection topics I need to air out. So let's dive right in.
Come on.
I think thermal cameras are one of the most important pieces of equipment that we use on a regular basis during our home inspections. So first, what is a thermal camera? Basically, it's a camera that is able to see a wavelength that is not within the visible spectrum, meaning that you can't see what it can see with the naked eye. A thermal camera has a sensor in it that is able to detect wavelengths of light that the human eye cannot detect. And what that means is that every object is emitting an infrared energy off of it. And that infrared energy is then put into the sensor, and that sensor then decides, based off of all of the information coming in, what is hot, what is cold, based off of the actual wavelength that it's receiving. And what it'll then do is color code it to say, okay, this is cold, so we will give it a color. Most of the time that color is going to be a dark blue or purple. And then this is warmer or hotter, and we're going to give that a yellow or an orange color, and every color in between. What that thermal camera does is not only take something that is invisible to the human eye, but it also takes that and converts it into an image that we can see, and then color codes it to make sure that we understand what it is that we're actually seeing. Now, one of the common misconceptions is that this allows us to see through walls, and the answer is no. It doesn't allow us to see through walls. All that it allows us to see is the delta T, and the delta T is the difference in temperature. So if we're looking at a wall, there may be some parts of the wall that are a different temperature than other parts of the wall. And why might that be? Well, if it's cold outside, we could have cold air infiltrating the house, or basically we have heat exiting the house. And so we will see hot spots and cold spots. What could this be indicative of? Many different things. An issue with air sealing, an issue with insulation, an issue with moisture potentially, because as that moisture is evaporating, it is going to make that surface colder. Those are all things that it's able to do, but it cannot see through walls. We use our infrared camera the same way we use our flashlight. If we walk into a dark room, we illuminate that room with our flashlight, same as if we walk into a room and we want to understand the temperatures of the walls, the ceilings, the floor, or the appliances within, then we use our thermal camera. That's what allows us to understand what's actually going on that we can't see with the naked eye. One of the methods that we use to show our clients how a thermal camera works is that I will take my palm and I'll put it right up against the kitchen cabinet. I'll hold it there for a couple seconds. Then I'll put my finger underneath the sink. I'll dry off that water so my finger's just a little bit damp, and I'll smear my finger across that same kitchen cabinet. Now with the naked eye, you can't see anything different. There is no indication that the cabinet is wet. There's no indication that anybody had previously touched the cabinet. Nothing to the naked eye. Whenever I pull up my thermal camera, we can see a bright yellow-orange palm prints to say that that's a warm area. And then we see a dark blue-purple smear across that kitchen cabinet that says that's where a damp area is, or where water is evaporating. Now, with that example, it's very important to make it clear that it is not a moisture meter. All that we are checking is delta T, the difference in temperature. Sometimes, whenever you have a surface that is evaporating water, it will be cooler. But sometimes, if that surface is completely saturated with water, there will be no distinction on that surface that it is saturated with water, because it'll uniformly be the same temperature. So it's very important to understand it is not a moisture meter. However, you can use a thermal camera to help you identify areas where there may be moisture. So what do I mean by that? You could see a cool area, and that may be an indication of moisture because something is evaporating. Additionally, you might see a cold area and it might only be an air leak. So what you have to use is a moisture meter. That moisture meter, if used correctly, will then be able to say this section of the wall is dry, this section of the wall is wet, and then that is a validation of the thermal camera that there is in fact a leak of some sort. Now, unfortunately, there are false positives, and there's a lot of them, and they come in many different forms. Some surfaces, such as the reflective surfaces of a mirror or a stainless steel appliance, those are going to reflect that infrared energy, and therefore they are not going to truly show what their temperature is. Or they may be reflecting something from another part of the house onto the sensor of your thermal camera. So it's important to understand how reflection affects things. Additionally, just because you see a difference in temperature doesn't necessarily mean that it is moisture, doesn't necessarily mean that it is an air gap. It could just be something called thermal bridging. And thermal bridging is whenever I touch something, I now know what its temperature is. Whenever I'm around it, I might feel some of that radiant energy, but if I held up a cup, you wouldn't know, is that cup warm or is that cup cold until you actually touched it. As that energy is being transferred back and forth between your hand, for instance, if your hand is warm and the cup is cold, that energy from your warm hand is going to that cup. If the cup is hot and your hand is its normal temperature, then that energy is going from the cup into your hand. And you don't know that until you actually touch it, and what that is thermal bridging. So sometimes you might see thermal bridging and think it is an issue where in fact it's just overly packed insulation. It may be improperly isolated components of the house, a lot of different things, but it's not necessarily a leak or another issue. And so you really have to think critically whenever you see things on that thermal camera. One of the primary use cases for our thermal camera is to identify whether or not an HVAC system is working. Now, not working properly, not working to spec, just is it working? Do we have heat coming from these register vents? Do we have in-floor radiant heat that is actually producing heat? Are those baseboard heaters working properly? Now we can't identify, wow, that baseboard heater is at like 200 something degrees. That's gonna burn your house down. We should probably notify somebody. We can also identify, wow, there's a cold zone in this in-floor radiant heat, or there's a big blob just coming out from that in-floor radiant heat, which would mean that there's a hole and a leak and something bad is happening. So there's a lot of things that we can do, but we are not going to say that we are producing adequate amount of heat or that the differential of heat in the system versus the return, that's all adequate. We are not doing those calculations. We are simply just saying heat exists whenever I ask for heat, cold exists whenever I ask for cold. What that camera can do is give us some definitive data. For instance, if you touch something, we've talked about thermal bridging, how that energy is being transferred from you to it or it to you. But something else that's going on that you should be considering is the thermal conductivity. What I mean by that is that if I touch a granite countertop, it's going to feel cold to the touch. But in that exact same room, if I touch the carpet, it is not going to feel cold to the touch. That is because of the ability for heat to transfer from one surface to the other, or the thermal conductivity is going to be different in those two materials, even though they are the identical temperature. And so sometimes if you touch something with your hand, you may be under the impression that it is cold when in fact it is not. And the thermal camera allows us to do that. However, again, for definitive data, we then, for certain things, such as a leak, need to have something else, such as a moisture meter. But if you're using your moisture meter in ways that it wasn't designed, well, then you're going to be giving yourself false positives. That's a whole nother topic. So pretty please, if you're going to be testing whether or not concrete has moisture, spend the extra money to have a moisture meter that's designed for that, because most moisture meters, that's not what they're designed for. Knowing how much data we can get about the house using this device, and knowing that we don't charge our customers any money for this service, the question may be asked, well, how expensive is a thermal camera? And in general, they range from a couple $100s to a couple $1,000s. And of course, you can go into the $20,000, the $100,000 and beyond. But for the sake of home inspections, I really think you should be spending anywhere between $400 and about $2,500 to get a good thermal camera that has the clarity or resolution that you need to adequately perform the tasks that you want to be able to perform. The use of the thermal camera is always the last step that we perform in the house. And the reason why is because it is a type of CYA, or cover your ass. And what I mean by that is sometimes we can be going through a house and then use the thermal camera and identify a leak that wasn't readily identifiable before. For instance, we could have been running the sink, running the toilet, running the bathtub, doing anything in the kitchen, and there could have been a leak that started, but it was not readily identifiable. Now with the thermal camera, we have yet another chance to be able to find that, to give our client the important information they need to make the repairs before they take ownership of the house. The question is then asked, well, do we provide every single photo to the client? And the answer is no. We're going to provide the photos of the HVAC system working appropriately, the appliances working appropriately, and any issues that we may find inside of the house. What we are not going to do is we are not going to provide them every image of every part of the house. And in fact, we don't save or store every image of every part of the house because there are too many false positives. And whenever we see something on the camera, we then identify that as an area of concern. We then use our moisture meter or our other tools to identify what is causing that particular area of concern. And then whenever it has been found to not be a concern, then we move on from that. The last thing I'll leave you with is, if you're a home inspector and you aren't using a thermal camera, or if you're charging your customer for the use of the thermal camera, then on the inspections that you are not using the thermal camera, I think you're kind of opening yourself up to liability, because you have the tools, you have the know-how, and you might have missed something because you did not use the thermal camera. And if you don't have a thermal camera and you don't see the value in a thermal camera, well, then I would advocate that you not use a flashlight on your next home inspection and tell me how that went. Whether or not you were actually able to perform a top tier home inspection or not without a flashlight. Because again, we use our thermal camera the same way we use our flashlight. It is equally as important. What I'll say about purchasing tools, especially expensive tools, is that it's better to pay for the tool once than to pay for not having the tool for the rest of your life. And with that, That's a pod. Thanks for listening to Moose Tales. This short home inspection topic was brought to you by Two Moose Home Inspections and was intended for entertainment purposes only. Keep putting one hoof in front of the other and keep those ears perked up for the next episode. Thanks again.